My name is GINTARAS Pelenis. I'm working at EMC as a system engineer. So I'm going to try to run a bit through the ViPR in the general view. So those who haven't really been in the keynote will be something new. Those who have been in the keynote, don't fall asleep, please. All right? So what is ViPR and why ViPR now? So during the keynote, we actually have been speaking about the planes, about the pilots, about the autopilots, and the context behind that in a more understandable way. So as an example, we took this Boeing 747. This is actually 800, the new series. So this plane is particularly done with 6 million parts in that, and being produced in a couple of months in the factory, big supply chains there, and different people doing different jobs to combine it all together. That really kind of gives a bit of sense of the IT, how we do that today, right? So we have storage, we have the server, we have the application teams, we have developers, and other guys developing the things in similar fashion. So everyone is doing their own track. The only problem is about integration, so how it all works together. So in the Boeing, we have so-called autopilot, right? Which usually flies the plane on like 99+%. And normally, these guys who are actually the pilots, they turn on the autopilot, I would say, already at a couple thousand feet above the ground. So just a couple of minutes after you take off, you're already flying on autopilot. So on really predicted, scheduled, programmed way. So is there any difference here between how you do that with your IT? Right. So in IT, we still try to get these autopilots running all the time. That's what VMware has been developing in the last couple of years. That's what we have been doing at EMC in the last couple of years. So getting more intelligence, abstracting intelligence out of the hardware level and putting that in operational level, more or less. So these kind of silos of servers, storage, networking, applications, Oracle, Microsoft, VMware, just name that, they're all being kind of pushed into a bit of more automated, fashioned way. So with the common management across the platform, that been already in the market for a couple of years, we consolidated the servers, again due to the Intel enhancements mainly, due to VMware breaking out. We've done a bit with the network on that area as well. So think about converged networks, been there for, again, more than 5 years, I would say, maybe 6 years. So when other vendors, I think, like HP and Cisco pushed really a CoE in the market, or the convergence itself. And I mean, that's been progressing some of the way. We could rate that, better or worse, but that's what we've been doing, right? And the critical things, and Angie as well was talking about that quite a lot. In the virtual data center environments, it's very important to get kind of the pools of the resources, right? So it's not about really setting up your server and deciding that for the one application, but rather than getting a farm of the servers and then balancing that with the different applications on the fly, depending on the workload and depending on what type of tasks you have, what kind of business context behind that. Then we talk about abstraction, so trying to get a bit rid of the direct physical engagement with the infrastructure itself. Either it's server, is it storage, is it network? So we try to automate that as much as possible, right? And every vendor in the market, even if it's HP, IBM, Cisco, Dell, they have been creating the management suites to manage the servers. Think about Cisco, Brocade, Juniper, they've been doing that for the networking part. All the different storage vendors doing the same for their own piece of the hardware, right? So that gave us kind of common glass of the management, but still again it left for the single product as one. To make that really automated, we went through the models like ITSM, ITIL, really to get the business processes running, more or less, or IT services. Then we try to put things like orchestration engines, automation engines, and different things with the flows, build them, and try to make them work all together. And after that, really deliver that for the end users. Either it's through the portals, self-service portal, either it's through some kind of managed applications. We really were finding the ways, how to get that in the kind of that automation context. And that really goes into that big power of three, right? So we're talking always in infrastructure about kind of 3 critical components: server, storage, networking, more or less. We think about automation, abstraction, and pooling resources. And that's kind of the three key components for every virtual data center or IT as a service game. You're going to try to do that internally. Rating, Magnus in the morning, together with me, was talking a bit about how well we've done. I just got a glimpse of that in just previous couple of sentences. So I would say with the computing, we've been quite far with that, right? So would rate that maybe 8 out of 10. We still have some games to do there and some enhancements to do that. But anyway, with the computing, I would say we're pretty cool there, abstracting that, really getting rid of the hardware direct integrations or kind of direct touch to the hardware, and really moving that with the vSphere or other solutions a bit up. In the networking part, not really that much still. There have been acquisitions by the same VMware done like Nicira for the software-defined networking, right? We're going to have a couple more things going out in very short period from now on. You're going to see these enhancements going from the same VMware. A lot of vendors in the networking side really looking how to do that abstraction out of the networking side. And with the storage, I would say we just started, more or less. Again, we don't have that much virtualization around the storage area for the moment, still. But we're trying to get there. We had some abstraction inside the box itself, a bit outside the box. But still it's far away from the orchestration engine. So what we really done is that looking at that kind of autopilot sense, so doing everything in an automated and fashioned way, we wanted to build a solution or a product which could actually extract the storage up. Definitely is going to be the journey. We've been talking the last 3-4 years about the journey to the cloud, to the private cloud, to transformation, transforming and leading transformation this year. How to do that, but how to get really that autopilot in place. So most of the things in the, again, big three, we're putting intelligence a lot in there. And that intelligence worked, again, as we saw the rating, right, the scoring at least. So for the computing, we have quite so far good there. With the networking a bit, with storage, it's kind of tough. So we put that kind of intelligence a bit above the stack. So try to abstract that intelligence and put that work on a higher level, in the level where the service is being created and developed and produced in that way. So moving that again and stacking up in the abstraction layer. So again, Andrew discussed vCloud Suite, vCloud Automation Center, amazing product to really get that intelligence in there. So all of the focus and effort here being putting intelligence inside, abstracting that, and putting that in automated, fashioned way. So really getting that orchestrated and automated, so we can deliver services like 1-2 click, finish, done, or visitor-based. So this ended up with a storage story. So introduction here, I should be very excited about that, right? So software-defined storage, or the product we call ViPR. Now, right? So it's extensible, it's easy to use, and it's very automated product in a way, how it's done. Again, two components for those who haven't been in the keynote. So ViPR is mainly consisting of the two critical components. So the data plane itself, so where the data moves in, and the control plane, where we handle all the operations for orchestration and automation. So these two core elements will be the kind of foundation of the ViPR in the future, how we're going to deliver and develop more functionality on the way. Out of day one, we have the integrations currently with almost entire EMC portfolio. We already have that integration with the NetApp natively now, and we're ready to do that for the third parties. I'm going to get to the point when I'm going to speak a bit about the API, how it's developed. But ViPR is using the open API, so anyone can actually write the plugins or write the drivers for their own system. So even if you have the commodity hardware, which you have been created yourself, you can do the integration with the ViPR platform easy. So it's very open and very easy to use. So any vendor on the market, either it's HP, IBM, whatever else, just name that, they can actually get plugged into the ViPR in an easy fashioned way. Either the vendors themselves do that, or you can do that yourself if you want. So the way how it's done. So in the basic controller, when we talk about the kind of data plane, we more or less think about automation and orchestration. So how the things are done. We're talking about discovery processes, about the provisioning, about the reporting, correlating all the events from different platforms into one single piece. ViPR itself enables you to really combine different storage platforms you have. Not really by one vendor, but from the heterogeneous vendor environments. So you can take 3, 4, 5 vendors and put them into single virtual array. then you can provision that as one big virtual pool, carve the lens, and give them to the host. That is the original idea of the ViPR. The ViPR is not the storage virtualization platform. So ViPR is giving you automation all the way down. You can still use intelligence, which resides actually in the box. So think about functionality like the snapshots or clones or tiering functionality. You can still leverage that from existing storage array vendor, like EMC, FastVP, or fast cache functionality, or snapshots replication, and other services. So the data plane itself, where the data really goes through the host to the, let's say, the physical array itself, it really remains kind of transparent. We only do the kind of configuration automation as of now on. The very bright future behind is really to get even more abstraction. So really staying a bit more than the software, than the hardware vendor from the terms of the EMC. That's what we have the goal. I'm going to show you a bit how it all going to combine together. So in general, when you do combine these virtual arrays into one, you're actually creating so-called self-service catalog. The thing you can find on any website while you want to go and buy something, at eBay, Amazon, whatever. You're going to have the catalog offerings. So that's the same what ViPR does for your internal IT or for your storage. So you can carve different services for different applications, for different performance requirements. Every single time when we get the intelligence of the array through the APIs, we always look at what's actually technically in the array. So when you think about the connectivity it has, about the performance it has, about the extra data service capabilities like snapshots, replication, and other things, and group by that. So it's not going to end up that you're going to have the high-end array mixed really with the low-end arrays in one single pool. You're going to have like gold, bronze, silver, and whatever pool else you want to name. So we're looking really exactly in the array itself, what it does and how it performs. It can be block, and it can be file. And it can be object over file. That's the new era of doing things at the web scale. So it also supports the object access, and we have different kind of movements around that. So ID can be applications using ID direct access on the file systems. So you can leverage your existing NAS systems and convert them into object storage, if you like. That's also a possibility to do. So what we do next is we plug in that into the VMware, or the software-defined data center as we call. For the moment, I would name VMware as the only software-defined data center as of now in the market, from all the vendors which we have, right? So we can do that through the management monitoring integrations, if you could name that. We can do that through the automation, the cloud automation. We can put that in the cloud suite. We can integrate that over like 90 different integration points with different functionality. And in the future, think about the same SRMs and other functionality done. VDP, VMware Data Protection as well. That's in the nearest, brightest future. So what else with the ViPR? So we're going to have the integration or kind of the primary reporting engine for the ViPR, so-called Storage Resource Management Suite, which is the SRM product by the EMC. So you can get all the graphic reports or representation of the ViPR clusters in the SRM suite, which has a couple components inside. The primary repository for that is going to be the Watch4Net, the company we acquired a year and a bit ago. And very flexible and easy monitoring platform, very extensible, and then really, again, to support solutions and monitoring capabilities at big scale. So I'm going to show you a bit of how it looks like. The next one is the Service Assurance Suite, which is the part of our old Ionix family, which most of the product now in the VMware you see actually came from the Ionix, which was a part of the EMC previously. We moved that portfolio into the VMware some years ago. And most of the automation you see now in the VMware actually happened on the back end of Ionix. So the Service Assurance Suite is also Ionix product. We still maintain that in the EMC. It allows you to build the automated configuration management capabilities for your networking, for your storage, for your services. It also provides you with the compliance reporting if you want. So you can have your own compatibility matrix for all of your devices, servers, applications, networking devices, and so on. And you can check them periodically if you want. You can check them ad hoc, schedule basis. Does all the configurations on my network devices are against my compliance. Servers against my compliance. Security policies in my application, do they comply with my own rules? So that's the service assurance suite, what we do. And the ViPR itself can do the representation at some scale. If we look at the services itself, a bit discuss that. So we do the file, we do the block, we do the object on the file. So meaning that the big difference here between the file and the object is actually the metadata, or the state of the file. So instead of having just a PDF report, I don't know, end of the month financial report converted into the PDF, you can actually create the object, which will have the metadata associated and the status of the file associated with that. So during these kind of metadata creation, or the application which creates the metadata, you can set up different parameters with the file. So let's say the application copies. You can set up the amount of replicas you want to be associated with the file. So anywhere the file will end up, it will must have 3 replicas. And that's going to be the metadata which will be associated with the file. So any system which will receive the file will definitely going to do the replication of the file. Think about the retention. You can lock the file down for the year or 2 years or 3 years, not really to allow it to delete that. So that's also part of the file itself. And a lot of different parameters which can be going through that. We have the solutions at EMC called Atmos to really support the object storage and the API-based access to the files, but ViPR is actually getting that directly through the NAS storage now. So that's amazing functionality. If you think about all the new type of applications, so-called third generation, which IDC names that, so mobile access and things like that, it's definitely going to be the objects. Amazon has free support as well. It's natively now in the ViPR. So you can automate the Amazon S3 deployments as of GA, which is like now, well, 3 weeks ago already. Meaning that you can automate the same way, deploy the stores locally in your infrastructure, plus move them to the Amazon S3, if you like. That's also built in. So again, object support there. If we look a bit on the advanced functionality or advanced data services, what ViPR is intended to do in the future, think about the backup. Backup always has been more like the software defined, right? There never been much of the backup appliances themselves or the hardware pieces who could do the backups normally. So the backup normally was the primary function of the application itself, plus we got the backup software which could handle that if the application is not capable of doing these things. But more or less we always spoke about the software. So if we want to tie the backup together with the data, we can simply move the backup inside the ViPR on the advanced data service level. So placing the backup as a data service. So while you provision the storage, either it's file or block on object, you can already associate the backup policies with that. So every single offering you're going to have from the service catalog will come in with the backup policies defined. Retention periods, how much to backup, incrementals, fulls, schedules, everything can go there in an automated fashioned way. Again, think about applications. Application integration, to understand how SAP, how Oracle, how Microsoft and VMware works. In the VMware we have the product called VDP, now in the latest release. It's actually built on the EMC Avamar kernel itself. It sources the duplication engine. So you can do the direct backup from the VMware ESX host down to the VDP clusters or to the Avamar as a single data store engine, directly bought by the EMC. And you can do the source duplication, you can do encryption on the fly with the data, and another different data services for that. The next one would be the mobility and replication. This year we already announced the virtual recovery point. The recovery point is an amazing product. It's, I would say, kind of unique on the market. It offers you the replication capabilities with a built-in journal inside. So mainly you can get with any applications, any point in time, back or forth, if you see that you have any failures with the data. So it resides on in the data path and keeps the journal of every single I/O operation which is going down to the underlying arrays. Together with ViPR, what it enables you to do the replication between the different heterogeneous arrays. So think about the replication between, let's name them, I don't know, IBM and HP. Try to do with the native tools, try to do that with industry tools, or try to get that with the ViPR. You're going to have that done in an automated way, first thing. You're going to abstract everything out from these different heterogeneous storages, first thing. The second, you're going to tie and couple your application and the backup strategies together with the data and your volumes, right? So you're going to do that in an automated way. So it's very easy now to build very resilient architecture. Every single solution you're going to build will be built on the same pattern. It's going to be done by the same template. So you're going to have the same assurance level across all your different applications and your data residing there. So recovery point, mobility, VPlex, storage virtualization capabilities. I want to get two storages, two different sites, and present them as one single volume to my host. I'm going to use VPlex virtualization for that. I'm going to take one volume, one LAN from one storage. I'm going to take from another storage, another LAN. I'm going to merge them into the mirrored LAN and present as one to my host. When one of my storage fails, I'm going to have the data already in the second one, and the disk will be the same. So there's no connection loss. There's no data loss. We're talking about 0 RPOs and RTO times, more or less, with the ViPR. That's more like the big picture of the ViPR, how it looks like. So all the ViPR controller data plane, the ViPR data services for abstraction automating things, and advanced data services for keeping and maintaining the data. In EMC this year, we have the discussions about the cloud, big data, and actually we put one more tenet for that, is trust. So how can you trust your stack from the top to the down layer? And trust is not security. We're not talking about securing the data. Well, security is part of that. But the trust is actually, can I be sure that everything I do from there to there works? How the pilot can be sure that when he uses the autopilot, the plane will not crash or do some tricks with that. It's about the way of testing and doing the things always the same way. So it's very easy to find the errors. You can test that, you can find the errors, you can fix them, and you maintain the same trusted path all the way down, from top to the bottom. So all the advanced services, from the backup down to the creation of the LAN itself, is going to be in the same format. If we think about the VMware itself, so how you provision your servers, you can always use the master images, or gold images, or cold. True same for the VDI, true same for the servers themselves. Single patching, single console, same patching mechanism for all of the users consuming either the VDI, the desktops themselves, or the applications. So you just push the application and it becomes available for all of the users through a single portal. That's the new way of doing things in the right way. Let's name that way. Open development. So as I mentioned already initially, the ViPR is really built on the open standards. So the API, which resides in the ViPR, is really open. We published that for the community. That is, I would say, the critical point. So everyone really can build in and plug in their own existing hardware pieces. We had a lot of customers worldwide who actually asked that functionality. So they have been building their own data centers. And think about the companies like the Facebook, like Google, like Amazon, Yahoo, and others. They're not really much buying the vendor solutions. We actually had one of these big guys recently buying from us a bunch of petabytes, actually storage. And we're saying, come on guys, that's cool. I mean, we just sold like, over 50 petabytes in one order. That's like, we should be happy. And they say, I mean, don't be happy. It's only 4% of our entire environment. And I stand there and say, oh, sorry. So these guys have been developing their own platforms, and they still want to use the same functionality. So they can plug in through the open APIs, actually, their own existing environments, getting that automation layer up and running. We've been funding a lot of projects, actually, and working a lot with the Puppet Labs and the Razors. So the products for provisioning massive amounts of servers. Some of them are free source, actually open source and free as well. Some of them are a bit payable. But you can deploy, if you wish, 1,000 million servers in just a couple of clicks. It's just automatically done. Try to provision all the servers that Google has. You're not going to do that manually. It's impossible, right? The guys who've been working in data centers or are working in data centers, and I see a couple of them here, you must probably also know these stories, how the guy goes in the data center on Monday with the drives, goes there and just replaces the drives. As if you have quite a lot of storage arrays in your environment, a lot of drives, you're going to see huge failure rates. You're just going to go there twice per week and just change the drives. Do nothing, just changing the drives. And just they do fail. So if you're not really automating that, you're going to end up with a bad situation, data corruption or data loss. So you have to really rely on the controller capabilities, RAID capabilities as these. Well, there are much more stories about that. Again, think about the Google car, how well it done. It had only a couple of accidents. The first accident happened when the driver actually sit at the wheel of that Google car, which is autonomic, right? The second one, when the girl bumped into the back of the car. So the car itself had no accidents, and it drove, I think, 1 million miles, something like that, more or less, or 500,000 miles. So, I mean, humans are error prone. Most of the accidents that cars have, more than 90% happen because of the human errors, not of the failures of the components built in the car. That's what we're trying to get at, abstraction. The same story goes with the VMware, the same story goes with the EMC. We're trying to get really the software company. That was the promise done last year already by the Pat Gelsinger, which is the current CEO of the VMware. By year 2016, we're going to have most of our products shipped into the software versions or appliance versions. There will still be the customers who like to touch, the bare metal. I mean, they like the taste, the smell of that, or the, coldness and warmness of that. But the world is changing, and the change is already happening. If we're not going to go with that, we're going to stand up a bit behind that. Okay, more deeper look. So during the keynote, actually, I showed a couple of print screens of the ViPR itself. And we have, I think, them rolling in the expo booth as well. A couple more deep integration kind of videos, which we've done with the ViPR. We have the ViPR deployed a bit overseas here, but due to possible attacks we have recently got in our channels or errors, we really were not that brave to do that live, because always can happen. As we say, the demo demon strikes on stage usually. So the demo stage is a bit hard. So that's really the landing page of the ViPR. When we do start with the environment and we don't have nothing. So we have 3 basic steps to do. One is discover everything. So for discovery, we use the APIs and the plugins, right? So we take the plugins, we get them in the ViPR, we find and discover the arrays, and we get them in. We soak all the intelligence the array has. Amount of the drives, performance, services, functionality. Everything what's built in the array, we get that up to the ViPR as a data we need to check. After doing that with a couple of arrays, we simply create one big virtual array. So the new way of managing resources in the backend. Out of that, we're combining the storage pools. The storage pool kind of abbreviation or the naming itself comes from the EMC storages we did. So the same abstraction layer we already built in the storage systems, but this time we just got them a bit up out of the storage box itself. So after really getting that discovery done process, we simply end up with this service catalog offering. There's some pre-population done. So we have the basic services available there for the VMware, for the Hyper-V, for the Linux system, for the physical server, block and file, both. You can stay with what we have here. You can build it in your own. You can edit everything. Most of the pre-population extracted through the plugins end up in the groups. So we're going to link the storages by the fiber channel, iSCSI, CIFS, NFS, linkages, by the location, physical ones. So, I don't know, Vilnius, Kaunas, could be different locations, and we're going to group them by these parameters. Then while doing the provisioning in the service catalog, we can actually take these locations and take that metadata allocation we already collected and pick up that as a drop-down menu. So you can rebuild a bit the service catalog if you like. You can also put there, let's say, the zoning. So the zoning is usually done, or kind of mapping the LANs, physical LANs to the hosts, is part of the automation process. So you don't really need to do the zoning separately. So if we provision the LAN for the host, we're going to include the zoning part as well on the rules we're going to define. So dual paths, single paths, just name that. It will depend. So we're going to have the couple other opportunities here. So as you see, I mean, Linux server creation and zoning path. You can create the capacity limits as well. So you can define your own service catalog offerings by the capacity. You can do that always later when you select the service from the service catalog. But that can be built via editing the service, so you can define them already. You can get that service catalog for the different guy in different view. So if you're talking about the developers or that's dev team, let's say, UAT team, you can always get for them already pre-built offerings without possibilities to change them. You can integrate the approval flow inside. So, because it's open API based, you can mainly ship the API or intelligence from the ViPR to almost any IT management system you have in place or in your company. So approval is as well working. Execution windows. When I should do that provisioning? During the day, during the night, immediately, on a scheduled basis. So that's also possible to be done and defined in the ViPR. So much more data, right? So when you finish building the catalog itself, you're going to have that pre-populated. You remember I saw in the slide previously there was Hadoop clusters, Oracle clusters, and the other services available as well. This is very basic what comes with the ViPR. So if we look how it's really done with, say, the VMware farm, you get the subtenants. So for VMware, we have these defined tenants. So creating and extending the data stores and the volumes, creating the volumes, deleting the data stores. So different options available as well. After you're going to click in a subtenant, the service, you're going to get back to the wizard itself. So you can a bit adapt the things. There are some things pre-populated, but you can still choose your resources. So you can take the city locations, you can take the ESX hosts, you can take the vCenter servers, which are managing the hosts in that specific area. If you talk about the 2 or 3 different data centers or 2 or 3 different cities, or maybe the aisles of different vCenter server farms, you can always select for which vCenter server you want to present the host. So you're going to get the list of the servers or hosts available under that vCenter management, kind of the child's there. You can select the cities again, put the namings, different ones, and then you go actually for the already provisioning itself. So if no approval process is required, you're going to start doing that automatically. If the approval process will be required, you have to wait till the approval is done. So it's going to go to the IT management system, and someone will have to approve the request itself. If there is no approval involved, you're simply going to get here, and the provisioning will start. What we're going to do again, we're going to check down through the same plugins and APIs the underlying infrastructure. Do we have enough ports? Do we have enough free capacity? Do we have enough performance for that? If we have everything clear, we're going to have the prerequisites accomplished. We can start building already the volumes. In this particular case, we're building the new data store for the block access for the VMware. So you're going to see here the commands, the script commands actually, which you would normally use in your ESX hosts while you do the provision. So it's nothing really specific. It's everything what you could do yourself manually, but in a very automated way. So the ViPR is really about the choice and openness. We do that in an open way. So finalizing all the steps here, you're going to get the resources available. So you're going to get the resources created, the data store is created. Now you're going to have the initiators, which can be shipped to the vCenter server and map that to the host. There's another way to really do that through the same vCloud Automation Center. I removed that slide, I showed that through the keynote. So vCloud Automation Center actually has the possibility directly to interfere with the APIs underlying above the, let's say, the GUI of the ViPR. So you can do the same steps which ViPR can do through the vCloud Automation Center. So meaning that now you can provision servers, network, storage, applications, and user computing, whatever else device you want. Very flexible way, one single console, one single GUI for managing the things. Storage resource management, as I spoke, the primary vehicle for exporting the reports and the correlation of the data. Here you see the Watch4Net interface. The Watch4Net is more like the core of the SRM suite. The product we actually acquired, again, a couple of years ago, and it's very flexible, very easy to deploy. In the Watch4Net, you're going to get the report back for the ViPR. So it's going to send you all the information, shipping the data, correlation alerts from all the underlying systems, and showing that in one single pane here. Watch4Net itself is a very flexible platform. As a separate product, it can enable you to track all of your networking, servers, applications, storage, even GSM LTE devices. mainly whatever you can name, whatever you can actually export through the open APIs, you can put into the Watch4Net for monitoring and reporting capabilities. So Watch4Net is a very flexible platform and supports almost every single vendor I ever seen on the market. So the same goes with the ViPR. And here we're going to have a couple of examples. On the resource management, the ViPR, how it works itself. So we have different type of services like block and file, we have the health and visibility. The same report can be shipped to the vCenter operations from the VMware. So you can get these two engines, both of them are actually learning. So either Watch4Net or vCenter operations, you can feed the information there. Which screen you like the better, the one you take. If you want to have the full visibility over your infrastructure, Watch4Net is ideal for that. On your virtual environments, definitely will going to be the vCenter operations. And still can be the Watch4Net as well. So you can all combine them together as one. You can see different options here with the resources available again. So what type of resources you have, what storages you provision, what applications, if wanted, right? Everything is possible to do. Watch4Net also gives you the way on service level agreements or SLAs themselves. You can track actually the SLAs. You build in the rules for the SLAs, availability, uptime, quality of service rules, IOPS, megabytes, latency, whatever. And you can get that in very representative way, either percentage or colors, if you like green, yellow, red, if you maintain your SLAs or no. You can get that report exported in different ways. Very detailed for the technical persons, high level for C-level people if they want to track or keep the trace. CIOs, CTOs, all of these guys. Again, different capabilities. Here we have the high performance volume, so you can track the performance as well. So everything again for the single pane of glass available in the system. So ViPR itself is, kind of in wrapping up, is really built for the scale. It leverages the Cassandra database in the backend. So Cassandra, if you're familiar with that, is the database really suited or fittable for the web scale. So you can deploy ViPR if you want at one location. You can deploy that at hundreds of locations, 1,000 locations. You can do that for the web scale as well. If you want to be the next Amazon, you can use ViPR. It will support that as well. So a lot of elements, a lot of storage arrays, a lot of operations. It's really built for that. You can be the service provider, you can be the enterprise, you can be the very small organization. It will fit all the sizes, more or less. So to really sum up, the ViPR, how we tell that is really virtualize everything with no compromise. So you're going to maintain, again, the same data plane. You're going to use the intelligence of underlying infrastructure, but you're going to have a high level of abstraction for automation and orchestration, as with the first release. So, thank you.